Hey everybody! The purpose of this video is to give you a visual for question E10 in the variation homework. That's the one that refers back to question E2, which refers back to a data set from the textbook. I believe it's question number 8 in the textbook in, I forget which section, but you can hone in on it if you kind of follow the path from question E10 in the variability homework. So in that one, we have an original data set given to us, 10 data values, I believe, or something like that, 10 or 12 data values. We have an average of them and we have a standard deviation of them. So let's do a real quick recap there. This is them down here in blue, just like it was on the other video for this data point in the previous problem set. What you're looking at in the standard deviation of 3.5, roughly, is the average distance that these data points are from the mean, which is indicated here by this diamond. Okay, so if you look at this data point right down here, which looks like the -3, -3 to 3.5 covers a distance of roughly 6.5 units. 8 to 3.5 covers a distance of roughly 4.5 units. 6 to 3.5, roughly 2.5. 5 to 3.5, 1.5, and so forth and so on and so forth and so on. If you sum up all of those deviations and call them distances, I should call them distances, not deviations. If you sum up the deviations, you get 0, and that's what question E11 asks you to prove for extra credit. But if you sum up all those distances and average them, you get roughly the 3.5 deviation that's up here in the box. Okay, and that's kind of the straightforward question number 8 that you did in your homework. This E10 says, what if you decrease each of those data points by 5? So take a look up here. 3 decreased by 5, -2. 8 decreased by 5, +3. 1 decreased by 5, -6. So you can see where each of those is in these green triangles down here. This guy was the -3, he's now shoved down here to -8. This guy was the -2, he's now -7. -1 is now -6, and so forth. The highest one, 8, is now +3. 6 is now +1, and so forth and so on, all the way down. What I've done is I've run the average on Excel. Please notice that the average is down 5, just like you knew it was from the previous homework set. The average is about 2 here, and it's about -3 here, and the difference is 5. We looked at that in the last homework. I also have a video proving it for you in general in that set. But the standard deviation, this is interesting. Check this out. It's the same. There is no difference. Now, why would there be no difference if you're doing a transform like subtracting 5? Well, let's think about why. What is the standard deviation again? Standard deviation is the average distance each data point is from the data set's average. Okay, so when we looked at the blue data set, we did a real rough collection of the distances. And we said if we average all the distances of all these data points from that average point, the average of all those distances becomes a standard deviation. Well, let's think about this. If the average was shifted down 5 units, and each data point was shifted down 5 units, has any distance relative to the average changed? And the answer is no. There's no difference whatsoever. This point, -8, is as far away from the new shifted average as the previous point, -3, was from its original average. This distance right here is the same as this distance right here. This distance right here is the same as this distance right here, and so forth, and so forth, and so on, and so on, all the way up to the highest data point being just as far away from the shifted average as the highest data point here is from this one. So essentially, even though the average changed and every single data point changed, they all changed the same amount, which means that the overall average of the distances didn't change one bit. And what's slick about that is you can go ahead and change this to any set of data that you want. Decrease it by 10, decrease it by 15, decrease it by 30. Now notice every time you do this, the data points change and the average changes, but the standard deviation doesn't go anywhere for the exact same reason. It can't change. It doesn't change at all. Hopefully that makes perfect sense. You can also decrease by a negative amount, which would be the same as adding. So let's decrease by -14. Okay? again, the blue data set appears as though it's flopping and flipping all over the place. It really isn't, and I can prove it to you by fixing the axis. I will fix the axis at a fixed maximum of 100 and a fixed minimum of -50, just to prove the point to you, okay? And now, when I change the data sets accordingly, you'll see the original data set staying right there, and the new data set popping around. And although the new data set is indeed bopping around quite nicely, one thing that's not happening is it's not stretching left to right, and it's not shrinking left to right. These distances are all the same relative to that average as these distances are relative to that average. And that's why your sample standard deviation doesn't change one bit if all you're doing is horizontally shifting your data. A different story occurs in E9 as you either read, tried, or saw. And we'll get back to that in the video. If you didn't get a chance to watch the video for E9, we'll get to that. I'll have a proof for you on the board. And hopefully this made E10 make a little more sense. Take care.